So here we go. We finally have a UI for Tunet. Go to the end of this video. I made installation for Linux and also for Windows. Just follow those steps and you should be ready to go. If you're not, if you already have it, just download this alongside the training file and it should be ready to go also. So let's do it. So let's open our UI now. So I'm already on the folder from Tunet and let's open. Here we go. So here's our UI. And now what I have, it's also a Tunet First project. So you can download this from following along if you want to do that quickly. So you go to the description, there is a link so you can download this and test for yourself what this project is. Let me show you. So I have this shot of this dog going out. Of course, this is a fully AI generated shot. And then basically I want to do some straightforward thing, which is basically a roto of the dog. And to do that, I did a segmentation of the dog going out. So we're gonna use that as a training to make that better, because as we know, segmentation is flickering, is not consistent. So let's fix that with Tunet. In case you guys don't know, this is SAM2 from Metas. Let me show that to you. It's this module here, SAM2. So basically it's a model that does segmentation on a lot of things. You can just select it or just ask it for the model to do it. And the module usually goes do, but it's a segmentation, so it's not temporal properly. One thing that it's good that it's coming version 3. So we're excited for that. And also something that's really, really awesome about this project is that they also made available the whole data set. So it's a very big data set with a lot of annotation. So this is good for us to train our own models. But for now, I'm just using the original pre-trained model that they have released. And that's it. And what I'm doing for, of course, this is a long shot. But what I did for sending for Tunet, I thumb warp it very heavily. So I'm jumping a lot of frames. And the goal that when we jump those frames, we want the model to be forced to learn that difference, basically. So we can see when we go there is a lot of frames. And basically I'm sending over 40 frames. And then the whole shot is 121, so Tunet has to learn a lot of frames. It could be less, I think, but for now I just keep it 40 so we can test our GPUs a little bit more. But sometimes even less is better because you want to force the model to learn the consistency, right? So let's do that. We don't need this anymore. Here we go. This is our Tunet UI, and then we have a few tabs now. Now we have the main tab. This is our data. So basically this is our data here. We want our source, which is our plate. So let's do that. Let's add our plate. Videos, Tunet First project. Our plate goes here. Now we want the destination, which is our, in this case, our masks. And then we need folder for the module. Usually I do module and I like to version it up. So V1, because sometimes you're going to test some different settings or whatever. So we can, have in different versions. So now we have everything ready to go. I'm gonna make this 1024 and I'm gonna keep this 128. For now, I'm gonna keep, 2, just to be faster so we can see what's going on. Let's keep it as it is. The iterations, the Dataloader. This is something cool. This is something that I think is really powerful. We're gonna make Tunet do a lot of variation for us. So basically we are making Tunet do some flipping, some transformations to the shot, and some tiny color correction This is all running on the fly, and this makes the model a lot more robust, because think ahead, the model has to learn different variations. So when they see new frames, probably the model is a lot smarter to figure out the new frame. So I like to doing this type of things. That's why I created this Dataloader variations. So let's do it. Let's start our training. So the convert tab is for something later, because we need our model first. So let's start it. You see, it's already starting. There we go. Here we have it. Let's have a look on our GPU to see how it's going. Here we go. So you see, it's 100%. This is what you want. And it's actually 70% so we're using. So we still have space. We could do a bit more batch size, so more data on that memory. But for now, let's keep running it. What you're seeing here of basically our shot on the left side, our references, and this is what the model has been learning so far. You're gonna see that we enable flipping, some transformations, and some color correction. So you can see the model is flipping. It's also doing some color correction. And this is good because this is actually forcing the model to learn new variations on the fly. But the trade-off that it's gonna take a lot more time for this model to learn. So if you don't have anything enabled here of variations, the model would be learning a lot faster, of course, but less robust. So it's something you have to learn and figure out depending on your project needs. You can actually, one thing that I have done here, it's like you can zoom and look closely. So you can see, oh, this is our reference. If you go here, how it's going to our model, because if you see fit, sometimes look good. So it's good to do some zooming. Cool, so the model is training, but this is not how I like to use Tunet. The reason is we are now using Tunet on this workstation that meant to be running Nuke or Flame. And then now we have to be waiting for this module to be learned. And basically, one of the reasons I created Tunet is that we run this on a server, on a new machine, or whatever, and we don't need to stop a full AAA box workstation while the Tunet is training. And so let me show you. I'm gonna actually SSH with XC, because that's the trick here. When you SSH with XC, it means if you have a monitor plugged into the server, you can open UI apps, and that's exactly what I'm going to do. So the machine that I'm going into right now, it actually has a monitor, and I can actually open Tunet. So let's go to Tunet. Let me conda activate Tunet, and now let me open Tunet, and that's it. Now we have a Tunet running on the server. Let's training this module on this server, which is a lot faster, and then just convert the module to running on Flame, which should be a lot better, right? So this is my workflow. So instead of using the Flame box, I'm going to use the server machine, which in my opinion, it's a smart way of doing it. And the reason I create Tunet in the first place many years ago, it's because I don't want my workstation to be occupied for a robot that should be on the server, basically. So that's my workflow. In this case, I don't want to use it. Let's just keep training for a little bit. So it is training here for, 5-10 minutes or so. So let's have a look on this training, just so we can see the whole workflow. So I stop training, see when I stop it, come back to green. So if I want to start training again, just start it. If not, let's just convert to Flame, one module. So here we go. I got my view one here. I'm gonna use the latest just in case, right? Open, and you can see that it's now converting to Flame, and it's done. So it's here, folder Flame. Let's convert to Nuke as well. So here we go, same checkpoint. So we have the same for both. Here we go. See, it's converting now, and it's done. So we have now a module to Nuke and a module to Flame, and then we are ready to go. Let's open Flame. And let's test the module, shall we? So Inference opened, that was in module view one, and then Flame, and then there we go. I'm gonna test it, of course, here before the time warp. That's what we want. And there we go. We already have some, it's already getting there. See, some frames and stuff. This was just like, I don't know, 10 minutes of training or so. So let's give it a test. Ooh, I don't want you. I want you. There we go. Let's play. Not bad for 10 minutes of training. And one thing that it's good to test it, like remember, let me go back there. Remember that we have on the Dataloader some variations, right? So we made the model more robust. So one way to test that, if we add some variation before the module, so here, so we need to do this way. Let me add some context here. And let me call that context. And now you can see like it's doing, is still holding up. And of course there is a way, one moment it will fail because then we didn't have way too much variation. So we get just some variations, but then the mod is extremely robust for those type of variation. I think even if you do like this, you see that at some point the mod will figure out again, because remember we also have flip during training. So the mod is really smart to variations to the changing to the plate. So that means like if this plates change for some reason, some, you know, I don't know, whatever new take, some variations, there is a possibility that the model will just figure out by itself because we got tons of variations in there. And that's it. This is the whole workflow. Let me go back there. You see, let's kill this bait. We don't need it anymore. And there we go. And that's it. This is the full training. This was actually just 10 minutes of training. So let's open Nuke here and let's have a look at Nuke. So let's open up our footage. Of course, we want the longest one because we want to test all the frames of the shot and not just what the model has been trained on. So what we have to do now is dragging the model that we just convert as well. So on the script, it generates like a Nuke script. So just drag and drop here to your script. And now all you have to do is plug and play, because this assumes you are using ACCG. So you have a color management here. And first you need to convert and create your CAD file, because the PyTorch is PT file. So now we don't need this anymore and we can just test it. And there we go, same thing. Really cool. There we go. Let's got some testing on our footage. So same there, same here. We're going to do, we need to bring this over from And whoops. There we go. And of course, we can have the same thing if you do some transformation to the plate. You can see that it's holding up. And same thing here. If you do the flipping, you also get there. If you go down, it's holding up. All right, so this is your Nuke, also working, the same conversion. Let's close this. Don't need to save for now. So if you want to keep training now, all I have to do is going back to my preview page and just start training again. The model should figure out by itself. You see there, resuming training. We're already in epoch 6, and there we go. And that's it, everyone. So hopefully this was helpful for you guys to get started with Tunet with UI. I'm hoping this is easier to get going and faster as well. And that's it. See you next one. Okay, so let's have Tunet install on this Linux box. This is Rocky. Should be the same for Ubuntu or any other Linux. So first thing to do, open terminal. And then make sure that you are using the Linux branch if you are in the Linux box, or if you're Windows, we should be going to the Windows branch. In this case, we are on Linux, so let's keep it on Linux. Next one, make sure you have Conda or Anaconda install. We're going to use this, so you need this install. Once you have that install, you're going to see this space here. So basically this means we have Conda on our system. Okay, so let's first one copy Tunet to our machine. Now let's cd, let's go to that folder. Cool. Now we need to create the environment, and that's why we use Conda here, because in the moment you have Conda on your system and now you're creating that Tunet environment, this means that whatever we do now, after we activate the environment, it's only affecting this environment. We are not doing anything else on the system. It's only inside of this environment. And that's why Conda is so good working. Now we have our environment and we are on it. We need to just install PyTorch. And again, we are only installing inside of the environment Tunet. We are not installing on the system itself. Now after PyTorch, we need to install some things that Tunet still uses. And that's it. We just install Tunet and we are ready to use. So all we have to do now is running Tunet, which basically have to run this command here, and we should be ready to go. Let's do it. There we go. Now we have Tunet UI ready to go. Okay, so now I have a Windows box here. And let's do the same installation on the Windows box. So the first thing we need to make sure again, it's going to the, not the Linux branch, but you're going to the Windows branch or other OSs. And all we have to do is the same thing. Make sure we have Conda or Anaconda install, same as Linux, and just following these steps. So let's get started with the first one here. Let's go to our Windows box. Let's open Conda and let's do the clone. We are now copy. Let's cd on it. There we go. Let's install our environment. So here, let's activate our environment. And now we need to install our PyTorch in there too. Then we need to install the things that Tunet need as well. So we go there. And we should be ready to go. All we have to do now is getting our app to run. So let's give it a try. And here we go. Here we have Tunet running on Windows with the UI now, and you have all the tabs to do the work and train your model. One thing, let me close, to have a look on Windows, sometimes it's really more stressful than Linux. So sometimes I like to run this command here. So I really recommend you after installation to try this command. What this command basically does to you is showing you that your PyTorch is running it. You also have an NVIDIA card running it and ready to be used. So if you get some failing in this, then you don't continue because you're gonna have fails. You have to figure out what's going on to your system. Usually update your Python, just download and install, and then you try to install it again. Use the latest and greatest CUDA and the NVIDIA drivers. So make sure you have the latest one until you got it a CUDA through with your PyTorch and showing that you have the GPU ready to use. So basically that's it. It's a little bit more stressful in Windows, but should be ready to go also. All right, and then of course running it, and that's it.